Hello and welcome to the webinar we are holding today on individual room control and efficient heating with KNX. So thanks again for joining us today. This webinar will be held live and we will look forward for your questions. So just feel free to post them in the chat and we will be happy to answer them. Notice info is that this webinar will be recorded and will be made available to all the participants after the event. So.
My name is Frederik Riedel. I'm the head and trainer of the technical service at Elsner Elektronik, and I'm your contact for all your questions about our products.
So hello again, and I'm Karim Boudiab. I'm an application engineer at Elsner Elektronik, and as a part of my daily work, I focus on the technical aspects of our products and their applications, in addition to providing support to the customers regarding the KNX products and their applications. So the question starts as, which of you have turned down the heating control when you left the house this morning? And as most expected answer is that most of us probably didn't do it. But please feel free to give us your answers and what did you do this morning? So is comfort and temperature subjective? So what do you think? Most people are familiar about this situation shown in this photo. So people's perceptions of warmth is very different. Nevertheless, comfort can also be achieved with comparatively low room temperatures. For this, we should avoid droughts and large temperature differences. This is because most people find them unpleasant. We would therefore like to have a look into the individual room control today. So our learning goals after this webinar, you will be able to determine the optimum temperature in different rooms, applying the principles of individual room control, to distinguish between the different modes of operation of the control types and apply them correctly, selecting the right room controller for the project. And through this, or to achieve this, we are going to follow this agenda. Optimum room temperatures, the principle of individual room control, the two-stage heating, and an overview of Elsner's room controllers, in addition to exercises, the room using ATS configuration and examples, and finally, we will see some data visualization and reports. Okay, so for the first part, we will see the optimum room temperatures. And before we deal with temperatures, we will have a look on how it could be different within different zones of the building. So the right room temperature has a major impact on our well-being. And the optimum room temperature varies depending on where you are. For example, in the office, in the bedroom, in the living room, or a fitness room. Only those who feel comfortable in their surroundings are correspondingly more productive and energetic. Here's a small overview of the most frequently used temperatures in the different areas. In the living room or study area, for example, the temperature is usually between 20 to 22 degrees. So for the principle of individual room control, we will have a closer look. Here we will have a schematic diagram of the room temperature controller. And this room temperature controller, shown on the box on the left, records the room temperature and sends the manipulated variable to the valve or actuator. The control valve is approached with a percentage value, for example 40%. The warm water then flows through the radiator or the heating circuit and releases its heat into the room, thus affecting the actual temperature. This room temperature can also be influenced by other factors. The room controller then records this temperature again, thus we are creating the control loop. And here we can see the direction of the logic. Okay, other factors can also affect the temperature or the control because the room temperature is not protected from external factors. For example, radiant heating from lighting, electrical appliances, or the people in the room can all affect. For example, one person emits a heat of output 80 to 100 watts. Weather conditions on the outer side can also be an influence to the room temperature, and this depends mainly on the building's insulation. All these factors are balanced out by the controller system so that the room temperature is normally kept constant. Okay, in this example, we show us a schematic or a representation of individual room control. It's illustrated as a Kala room controller, which compares the set point and the actual temperature and calculates the control value from it. The actuating variable value is sent in percentage to the heating actuator via the bus. This will open or close the actuator or the valve depending on the controller specification. As a result, the radiator emits its heat to the room. The room temperature is therefore always adjusted to the desired set point temperature. The red arrows shows us the hot water or the hot water flow to the radiator, and the blue arrows shows us the return water flow or the cooler water. So choosing the right control system depends directly on the heating system, and it's crucial for comfort and energy efficiency. The more inert the system is, such as underfloor heating, the slower and more even the control system must operate. So if you choose the wrong control types of the system, this can quickly lead to poor comfort or unnecessary energy consumption. As an example, we can see that floor or wall heating is a very inert system, and therefore a PWM or a continuous control with a long cycle time is used. On the other side, we can see an additional hot water fan heating. So to control this water circuit, a continuous PI control is used, and for the fan to be switched together with a hot water circuit, the 2-point control is used. So we will have a look into this example of two-stage heating. This is a special case. So in two-stage heating is usually a combination of a heating system that reacts slowly and in a combination or addition to a heating system that reacts a little bit faster. So we would say that in a floor or a bathroom, the floor heating maintains usually the standard requested temperature. But if a significantly higher temperature is required, for example, plus 3 degrees more, then the wall heating is also activated. This desired room temperature is then reached more quicker.
Okay, that was the topic from Karim. If you have some questions, then feel free to write the questions in the chat. You can make it on the top of the webinar tool. And I give you a short time for send us the questions, and then we will start with the next topic. Okay, I not received some questions, then we will start with the next topic. In the following, I would like to give you an overview of the Elsner room controllers. We start with the ETR 101. It's a simple room temperature and heating controller. The device has an integrated temperature sensor to measure the room temperature. The set temperature can be changed using the plus and minus over the touch buttons. The KNX ETR 101 have an PI controller for heating and cooling, which can be configured via the ETS. Karim will show us later some examples. I changed the view to my camera, and then I want to show you the product live. You see here it's the ETR 101. We have it here, and it's a very flat, easy design. And here on the back side, you see the connectors for the KNX and some other connectors for the binary and analog inputs, because we have the same products in two different versions. So very simple, very easy for the using. And I jump back in the presentation. The next device which I want to show, it's the KNX ETR 208 light and sun blind. The device has same function as the ETR 101, but it also has buttons to control the light and the blinds. The KNX ETR 208 is just an example of many with different combinations of the ETR family. Feel free to browse our web shop under KNX bus system and then ETR series. You will find a lot of different versions of the ETRs. Then in the third picture, we see the ETR 102 FC and the ETR 103 AC. I show you the FC later in some more details, but I want to change the view to my camera and I show you the FC and the AC version. The FC, it's for fan coil using, and the AC, it's for air conditioning. And the special thing on the AC unit is we have an integrated temperature and humidity sensor inside. And the price of the ETR 103, it's very attractive. The device is with KNX Secure, and the price, or the list price brutto, it's 119 euros. Also, it's very low for this good product. I change to the camera, and then you see the device in live. This one, it's the ETR 103 AC, and here you see the device next to with the ETR 102 FC for the fan coil using. And both have the same flat design with real glass surface. Okay, we jump back in the presentation. Here you see the mounted device. This device is frameless and can be mounted direct flat on the wall, or you can mount it on a standard electrician boxes. Here the device in some near view. It's the ETR 101. And here's the other mounting example. You see the ETR 201 in combination with the ETR M1. It looks very great, the design, and you see it here. We have other series, it's the Kala series, and we have a lot of different versions of the devices, but I want to show you here 3 versions of the devices which we have. Here on the left side, you can see the Kala Touch. It's a room controller with many different functions. You can switch lighting and control motors. It also has more functions, for example, human-centric light, RGB and tunable white lighting control. And it have integrated different timers. All of this integrated in this small device. The device is available in different versions, for example, with integrated temperature sensor or with temperature humidity sensor, or in the biggest version with AQS-TH, it's an integrated CO2 temperature and humidity sensor. And the device is made for mounting in the 55 to 55 mm frames. Then we have another device from this Kala family. It's the Kala 101. It's similar to the ETR 101, but made for the 55 to 55 mm frames. The device has an integrated temperature controller and a sensor to measure the temperature. All devices are available in black and white. And on the last picture, you see the Kala KNX Multi-Touch T, light and sunlight. It's a device which has a temperature controller for basic control without a display. You see the 3 points in the screen of the device, and with the 3 points you can make a base shift of the temperature. For example, you can make the temperature 3 degrees higher or 3 degrees lower from the base temperature. In the middle you find some buttons for controlling the blinds or other motors, for example windows, and on the top you find buttons for light control, dimming or switching. Also very simple, very easy to use. It can be used in offices, rooms or in guest rooms. Here you see the mounted Kala Touch device. In this version it's the Kala with the biggest version, the Kala Touch KNX AQS with temperature, humidity and CO2 sensor integrated. And the device needs only the KNX bus voltage for the function. So it's very simple to connect it to the bus and to install it. Okay, before we go into the next topic, did you have some question? Then feel free to write me. I will check it and then I will answer it in the next minute. I received some message from Fabio that the screen is not seeable very clear. Yeah, maybe it's a problem if you use Wi-Fi, then the transmission is maybe a little bit not so high in the quality. And the other option, you can use maybe the GoToWebinar desktop app. Sometimes the quality is better as in different explorers. Also, if you want to try it, then you can jump to the application and try it again. Thanks for the information, and we go on with the next topic. The next topic, it's about room climate control. There I want to give you an overview of different controller devices. Earlier we saw the ETR 102FC, which we have here in the pictures. The KNX ETR 102FC is a room climate controller thermostat, specifically designed for controlling fan coil units. The device has an integrated temperature sensor, and the fan speed buttons are used to set the fan speed in manual mode. The control is switched via the on-off symbol. When set to off, the controller is disabled, similar to a standard lockout function, and the LED is turned off. The ETR 102 features integrated temperature measurement. And here you see the main functions of the device. The next device, which we look in more details, is the ETR 103 AC unit. This device is a room climate controller thermostat, specifically designed for controlling air conditioned systems and VRV systems. The ETR 103 AC allows you to individually control the room temperature and indoor climate by selection operation modes. We have different modes for cooling, heating, dehumidification and ventilation. And the ETR 103 AC have a built-in temperature and humidity sensor. The built-in PI controller handles communication with the air condition systems via KNX and is compatible with the KNX AC and VRV gateways from leading manufacturers. I jump back to my camera and then you see the both devices again in the overview. Here it's the live of the devices. I show you this from the different sides. It's very flat design, very easy, very clean for the using. And the good thing it's simple. It's simple to use. It's a little bit difficult to show the right direction here, but I think it's seeable for all in the video. Okay, back to the ETR 103 AC. Here I show you the main things. It's a room climate controller thermostat for air conditioning, individual climate control. We have three speed fan and compatible with the standard AC gateways. So in the next we see a little bit more technique. It's an application example of the ETR 103 unit. In this example you see in the top the split unit with a gateway, and down you see the standard heating system with a KNX heating actor. And the idea is that you can control the two different systems with one ETR 103. If you switch the ETR 103 on, then the climate control starts with the manual mode of the automatic program. And if you switch it off, then you jump to the heating system and regulate the set point temperature. And both systems are locked, so if the cooling is activated, so the heating system is locked, and the opposite. Also very simple, very useful for these systems, and that was a quick example for the system. Yes, I see I receive no more questions. So if you have questions, you feel free to write us, then we will answer them live. And the next topic, it's from Karim. It goes more and deeper in the technical details because we look to a lot of examples from the configuration in the ETS.
Okay, so hello again, and here we'll take our first example on the ETS configurations. So for the first example, we will be configuring the ATR101 secure for a single stage heating system with a heating actuator. So I will go directly to the ETS. And here we can start our explanation. So first of all, we have the ATR, our controller, and we have our actuator, the KNX K4. But this K4 is not necessarily to be used. You can use any available actuator that you have in your project. We have this one as an example, and we can see the basic settings are being used. So we activated channel 1, and for this channel 1 we can choose the control type, and the most used or the default type is the 8-bit PWM. So you can use your own or another type of actuator, knowing that it has this variable control. So we move to our controller. Here is the settings of the ATR101. We have the general settings, the brightness, for example, of the LEDs, when to turn on if you want to communicate over external objects. And then we have the temperature measurement. We can use a malfunction object to determine if there's a malfunction in the sensor, an external measure value. We will get to it later. It's a very useful function, the transmission behavior, and to get a minimum or maximum value for recordings. So for the temperature PI control, we say that yes, we want to activate this control for our case. And here we see all those settings. So for the general settings of the control, do we want to maintain the threshold values, the extension times that are received via the communication object after the power supply restoration or not? What switch mode do we want? Do we have a 2 8-bit object, 1 3-bit object? We will also see those in example later on. The mode after reset, we can choose a comfort, echo, building protection, and the behavior of blocking. And an important feature is the amount of change. So what is the amount of change in which we want to send this new updated control value? Do we want to control or send this status on each change, so from on to off, or only when it's on, or only when we are out of heating, or we want to send it on a special period? This can always be set in this function. And then we move to the nominal values. And here we want to set our set points for the control. So we have the display mode, for example. We say on the display we want to see an actual value, the target value, or both. This value here is the increment step. So we say 5, so we can, when we click on the plus or the minus touch area on the device, then it will increment or decrement by 0.5 degrees. Additional settings are the comfort values. For example, we have the initial heating starting set point and the maximum and minimum values that I want to allow it to be within this range. Similarly, we have for the standby mode, the maximum and the minimum, the starting temperature, as well as for echo. Here we can see also an important feature, which is the nominal value for frost, which is frost protection value. By default, it's mostly used as 7 degrees, but you can always change it to a more convenient value of your choice. For example, a higher value. The activation delay is also an important feature to delay the frost if you want to air the room and you don't want it to directly activate a frost protection. And here the important also last part is the output of this regulator. we can see, similar as we talked before and we discussed, we see that some different systems have different values and that can be easily selected. So for example, an electric heating has its special parameters that are usually a standard, or for floor heating, another standard parameters. Nevertheless, we can still use our own controller parameters and set the minimum or the resetting time, which is the cycle time, and the maximum control variable reached, which is the difference of accepted change or the sensitivity of this controller. And then we can say the blocked value, do we want to send a special value, or do we don't want to use this function. So this is in general. And then we want to make it connected to the output. So we have our input ready and we want to connect it to the output. Here we can see the group objects related to this configuration and the settings. And then we can see both devices. So we have the output that needs this byte value, and we have the output of our controller, which will be then connected to the same actuator channel. And it could be relatively very simple. So we just connect both of them to the same group address. Okay, I connected by, okay, slipped. Okay, here to the control variable of the heating. And you can see also in the ATS, if you connected to a false by mistake to a wrong one, so one with a different data point type, then it will automatically notice this error. So this was a good example. After this, usually your system is ready, you just program those devices and it's ready to be used. You don't need to connect the set points now to any other external. It's a standalone system that can control everything and will control everything. So this was for this first example. So if you have any questions, please feel free to write us in the chat and we will be happy to answer. So it's also commonly used like to have a window contact to activate a special mode. So in this example, we have a window contact, the ATR1 or 1BA2, and also the same actuator that's controlling this an external valve. But for this, we would want to use a special mode or special settings in the ATS, and we will get to see how this works. We will first see on the actual connections, where is it done physically on the device. My colleague will show you this shortly.
Yes, I jump back to the camera. Here you see the ETR101BA2. BA means that you have two binary analog inputs. And on the left side, you see the window contact. And I rotate the device. On here, you see we have the button or the connection for the binary input. You see the EN1. EN1, it's mean input 1. And with the input 1, you can connect this window contact, which you can see here on the top of the window. And if you connect it there via wire, then you get the information on the bus or for the device, for the heating control. And Karim want to show us how this will work in the ETS. Okay, then we go back to Karim.
Yes, so we will have a look directly on the ETS and how to configure this function. Okay. So similarly, we have the ATR and we have the KNX actuator. The only small change in this application would be, instead of using the normal HVAC 1 byte value, we will use 3 1-bit objects. And I will get to this importance in a moment. The window contact, where my colleague showed you, is connected to the input. is set to be configured in such a way that when the window is closed, then a value of 0 is sent, and thus it's received on the bus. And when the window is opened, then we receive a value of 1. And this open and close condition of the window will control our mode of the controller. So we can see here the mode frost protection is now a 1-bit, and we have the output that we just configured in the ETR. Those two values need to be connected together via the same object. So I say my mode frost is connected to this address, and then the same address will be connected to the push button or the binary input. Okay, and with this configuration, I can make sure that my window will activate the frost mode when I open it, and when it's closed back, then I receive a 0 on this object, so the controller would know that, okay, no more frost condition, then it will go back to the previously set state, so a comfort or echo or standby. Okay, so I think we received a question. My colleague will support with this.
The question is, the input can be used for push buttons or for Rollladen. The question came from Raphael. I can answer them because we jump the easiest way is we jump into the ETS, and then we show you how you can configure the different buttons. You see here we connected to a switch, but you can say it should control a shutter, for example, or a blind. We activate this, and then you can set if the button should be drive up or drive down, and if you need a standard mode or dead mode or something that can be used. Also, if you not use it for window context, then you can use it for other things like shading, shutters, or to switch light on and off. It's like a normal binary input for the KNX bus system. Also comfortable, usable. Okay, thank you for the question. I hope now it's all clear.
Okay, so we will continue with the examples. And we now have a second example, which is an office space, a very common example. And in this example, it's usually an office area is very large, has much more room or space than a normal living room. So someone would expect to have two locations where he's able to control the heating or the cooling available in his system. And for this, we want to use an extension unit. And one of the devices that we are showing here as an example is this Kala Touch. This unit will be an extension to the main control, the ETR, and it will serve the same purpose for controlling our actuator. And also additional important feature is that in such large rooms, you can have different temperatures within this room. So it's not very uniform. For this reason, we could use from this extension unit the temperature and mix up the same this temperature value with the main temperature recorded on the other side of the room, and thus we will have a more uniform, homogeneous average value. So in short, this is the schematic. We have the main controller, the ATR, the extension controller, and the rest of our system. We will go again to the ETS to see how is this applied. So in the office area, okay, the actuator is configured also almost the same. Our main controller is set to, for example, here the mode comfort after reset, and we have the increment or decrement of the values for 0.5 degrees, and we say that we want to use an external measured value with a 50% weight. On the Kala Touch is a slightly different configuration. In the menu, we say we want to activate the temperature control. And then in the temperature measurement, I say that I want to send my measured value externally on the bus. So I say on change and periodically, for example, and those are the parameters to how much should the change be and the time cycle. In the PI controller setting, yes, this device can be used as a standalone, but also it has this function as an extension. So we select an extension unit, we set the same basic configuration as our ETR for the purpose that we have the same similar group addresses. And here I will start to connect so you can see how easy it is to apply this example. So I have HVAC mode priority 1. I connect it to HVAC, mode priority 1. Same as for mode 2, same as for echo, for example, set points. I connect it to the same echo set points on both of the devices. And then we have only one controller output, and it's here. So this control output, which is our main goal, will then be connected again to the K4. And thus, we are achieving the same set points or the same inputs that we give from different locations in the office, controlling our same output. So this was, in short, how we can easily apply this example. We will have a look to the questions again.
Okay, there is a question from Tim. Tim asks if it's if he should connect all of the objects, or if it's enough with the object which Karim already connected. I think Karim can explain this.
So that's a very important question. So when you are using an extension, we need to connect all the objects. So I will do this as an example. So we have the Kala and the main controller. And it's important that we connect all. It's important. So let's say I want to connect the echo heating. Okay, so this is connected. I want to connect the increment decrement. And I connect for both of them. And then I connect the comfort heating, the main set point, and then I say the increment decrement of the comfort. And this should be done for the two devices. So each group address will then be connected to two places, which is one on the main side and the other one would be on the extension side.
Okay, thank you, Karim. I think it's clear, and we want to go to the next exercise.
So we will move now forward with the examples that we have, and here we have a schematic diagram of a smart single room control. So the window contact, for example, is a reed switch. We discussed about this before, and is connected to the binary input of the Kala Touch. This 1-bit value present is now then converted to a numerical value by a processing module in the Kala. And this will change this 1-bit into an HVAC mode. Specifically, this means that when the window is open, instead of a 1 or a 0, a value of number 4 is sent, and which means that the temperature or the room temperature controller is in the frost protection mode. When the window is closed, then the value 0 is transmitted, and this means that the operation is reactivated, the automatic operation. Additionally, we have a presence detector, and this presence detector is connected to the HVAC2 priority input. And this ensures that when the presence is detected, the system switches to comfort temperature, and when there is no one present or no presence detected, then it switches back to standby mode. This is an efficient way to apply this desired function. And we will have definitely a look into the ETS how we can actually apply this. Okay, in this example, let's start with the parameter settings for the device. And here we say, yes, I want to activate the control, the same as before. We keep the switching mode via 8-bit objects instead of 3-bit of the previous window contact example. And then we go to the computer. So we need to use two computers. The first one is going to transfer, or it will compute the value of the window contact and send a 3 or a 3 for night or echo mode. And in this example, we will use 4. And then when the condition is not met, so the window is closed, then it will send back a 0. We will also want to use a computer number 2 to convert the value from the presence detector, so it can also send auto mode or a comfort mode. So when the condition is met, so when there is a presence, I want to send the 1 that I'm in comfort mode, and when the condition is not met, I then want to say, yeah, I want to move to standby mode, so I go to value number 2. Those are standard values that are available anywhere regarding to KNX. So in the inputs, I have to connect the same as before, my window switch, window contact, and then I will go to the communication objects. One more thing, I want to configure the intra-CV also, so it's the presence detector. We'll not go into details, we just say it's activated as a master, use master 1, and send the value with a switch off delay. So we don't want, if someone immediately exits this room, to change to standby mode. Rather, make sure that it's for a longer period of time, which is 30 minutes, and then switch to the standby mode. So here we have the group objects, and we have the HVAC priority 1, as you can see. And then the most important is now, we know that computer 1 will control the window, is receiving the input from window contact 1, which is our binary. So we need to connect first to the binary, the push button, because this is our window contact, and then it's connected to the input of the computer. And then the output, HVAC output is 1, is received from the computer 1 of the window, and the output of the HVAC 2 is later received from the output of the presence sensor. The motion sensor is now the input to the computer 2, and we say it's connected to the same output of the presence sensor. In this setting, we can then make sure that this, we still need to connect the HVAC1, sorry. Okay, so I made a mistake. We can go see it together, how to solve it. I have connected two different data points, and this is because I need to activate one more step in the computer. So this computer is sending a 1-bit output. I need to say it's sending a 1-byte output. And yes, I want to remove, so I will start clean again. And then in the group objects of computer number 2, you can see it's got removed. So I say this value is now connected here. I say yes, and then it's at the same time connected to priority number 2. and I say yes, it's assigned, and HVAC1 is connected to the same. And then this connection, we can make sure that our function is met and our desired operation is running correctly. So in the last example, it would be a living area where temperature control with a Corlo plus a mobile application. And we'll go back directly to the ETS. Okay, so in exercise number 5, we have the Corlo and we have the parameters of the Corlo. We want to achieve also a temperature control using the Corlo and from an external mobile. To achieve this connection or mirroring from the Corlo screen to your phone, you will need to have a LAN connection. You don't need any external connection. So on your local network, you say this is the information or SSID and the password, and you use the app on your phone and it will be automatically connected. So to now configure this screen on what we want to see on this screen, we want to say yes, we have page 1, and on page 1 it's the page name heating. I set the name for this page, and then on this page I need a special type. And this, for this scenario of heating and showing a temperature, I want to say I want to use a rotary control, which will be used as a set point control, and a one surface vertical, which will be next to this wheel, an area to display information. So the rotary control is now named as set point. I use a symbol 71. You can use other symbols, but those symbols are mainly each symbol for a specific case. We have it also on our web page. You can also easily access and see which symbol fits mostly your application. And here I say the minimum and maximum value of this wheel and the increment step, in addition to the starting value of the set point. On the next surface area, I want to show the temperature. So I say this is the internal temperature. I use a 16-bit floating point for the temperature value, and I don't want to change any factor. So I want to keep the exactly received value. Also, I can set the symbol that will be used with this surface. So in the automatic page, I go and select that yes, I want to use an automatic function, and this automatic function is a temperature controller. But one thing has to be mentioned, that we don't have an integrated temperature sensor in the Corlo, and for this reason we are going to use the inputs similar as our NTC temperature sensor. So we can say yes, this is an NTC, and then we send those values to be used by the temperature controller. We will see this in a moment. First of all, I want my temperature measured value, the most crucial to the controller. So I connect the temperature value to the NTC, and this one will be the input to my automatic function. At the same time, I want to see this temperature. I want to know what's the room temperature. So I connect it to the surface area on the page 1. And now I want to say that I want to control this to a target set point, that I want this room to reach so it feels comfortable. Then this wheel value that we want to move manually or by hand, then it will be set to the automatic value of set point, the input on this side. At the same time, this automatic function has an output as a feedback of this set point, and this set point is then taken to the same wheel where we can then see a uniform set point all the time, representing our target set point that is actually running on this thermostat behavior. So this is in short how we can achieve this control of Corlo, and using the mobile app you will be able to exactly see it mirrored on your screen. We will see this as an example. So as you can see here, Corlo displays exactly the same data directly into your mobile, and you don't need any cloud connection. It's completely local, and it's automatically recognized via the Elsner app.
Okay, thank you, Karim, for the last interesting topic. We saw a lot of different examples and useful examples, what you often needed in different areas. And I hope it was interesting for all the visitors. So the next topic is about the data visualization and reports of the measured data. Here you see an overview from a visualization. In this case, we use the iSphere visualization. iSphere is our partner from Elsner. And you see here a room overview from a floor. In this overview, you see different rooms with a color or different temperature regulator inside. And you can press, for example, to different symbols next to the devices, and then you come to different charts. And then you see the chart which recorded the data over a long time, for example, for 1 week, for months, or for some years. And so you know to which date was which temperature or which measured value in a room. And with this data and with the recording, you can use this to a report. And in the report, you see this on the picture. You can give a PDF export, or you can use this as an overview. And the report, it's in the top you see the room. It's in this case it's the living room, and you see a chart over the temperature which we had in the living room for a special period. And if there's something wrong, for example, you have set at a set point to 23 and you see the temperature is never reached, so you know there's something wrong with the heating system, and you can detect or look what's wrong with the system. Other option is KI can make an analytic of the data and can look what can be made better in the building. Maybe you can save some energy with the data, and they can give you some ideas what you can make for optimizations. Yeah, that's a quick look in the reports of measured data. I think maybe you have some more idea what you can do with this data, but it's also our idea how you can work with the data which you measured in the different rooms. Okay, we are on the end of the webinar. We are in the end, and so we say thank you that you visit our webinar. We hope it was all clear. And if you have some more questions, or if something is not discussed in our webinar, so feel free to give us some feedback via email or so on, so that we know what we can make maybe in the next webinar, or which topic we should extend the webinar. So feel free to write us, and you found here our contact data on the page. So you can notice our email addresses, write us, or you can find us on LinkedIn. Yes, and we will stay here for a few minutes in the webinar. You can write all your questions in the chat, then we will read them, answer them, and we are back in a few seconds. Okay, we not received some more questions, so I think we can close the webinar session for today. If you have afterwards some more questions, you noticed our data, or you contact us, our LinkedIn, We are happy to answer all your questions. We like to answer the questions and to help us for your project to use the temperature regulator. And yeah, feel free to write us, and we hope you see us, or we see us in the next webinar. On the top you find the QR code. There you see the next webinars on our webpage at Elsner, and there you found some different interesting paths to our webinars. Yeah, we wish you a nice day and see you to the next webinar.
Thank you.